Hey everyone, welcome to my channel. Today we'll dive into DeepSeek VL2, a cutting-edge vision language module. This module uses the mixture of experts MOE architecture to enhance performance and optimize computational efficiency. In this video, I'll explain its core components, evaluate its capabilities with structured test cases written by me, and summarize its performance with ratings based on the test results. I have prepared some test scripts to test this based on the official document which I read about DeepSeek VL2. There's everything about this VL2. It's architecture, data construction, training methodology, evaluation, and a conclusion. There is a lot to process here, but I just briefed everything into a small PowerPoint presentation kind of document. So I'm going to go through you on this video of my slides, which is basically brief of the original official document. DeepSeek is open source, which is available in GitHub. As you can see, all the data is available here as well. There is a demo available in Hugging Face. I'm going to do my testing and my test scripts on this. DeepSeek comes in 3 different versions: DeepSeek Tiny, DeepSeek Small, and DeepSeek VL2. The difference is that the parameters are 1 billion, 2.8 billion, and 4.5 billion activated parameters. That's the difference. And what we have is the small one, which is 2.8 billion. That's what is on the demo. So we are going to use that model. So let's deep dive into our analysis and then go into the testing. DeepSeek VL2 features a dynamic tiling strategy that enables it to handle high resolution images with varying aspect ratios effectively by dividing the images into smaller tiles. It ensures detailed processing while preserving visual information. This strategy is especially useful for tasks like document analysis, scene understanding, and visual grounding. So for this case, I have written a test case and we are going to test and rate that about this module. The test case is to test the model's ability to describe objects in dense images. So test steps are: upload a cityscape image and ask what objects are in the image. So let's copy the question. This test script is prepared by me and I created a UI to demonstrate testing on the process for this video. This whole thing is a small web app. Just for this video I made this one, so which will have few test cases and pass or fail, and I'm going to pass or fail and rate the response, and finally we'll look into what is the performance of it. First one, upload this image. I've got images downloaded already and keep it ready. This is where we are going to upload. So first one is the cityscape image. So I got this generated in AI. This image actually, this is a busy street with a lot of things. So I'm going to ask my question: what objects are in the image? So that is our test case, and what we are expecting result is the model should list roughly kind of as much as objects it finds in it, like buildings, cars, pedestrians, whatever it sees on it. Like if we see by our human eyes, whatever we see, it should be able to see as well. That's the whole point of this model. Let's see. It took like around 18 seconds to answer. Look at the answer. The image shows a busy urban street scene with several objects including cars, pedestrians, buildings, signs, and a cart being pushed by someone. That's pretty much it there. That's what I'm expecting as well to get the answer. That's what I expected as well. Objects like buildings, cars, and pedestrians, it got everything: cars, buildings, pedestrians, signs, and car being. So that test I'm going to mark it as pass, and I am going to rate it as yes, it finds everything, so I'm giving 5 for that. We'll go to our next slide, which I prepared. The multi-head latent attention mechanism in DeepSeek VL2 compresses image and text representations into compact vectors, enabling faster and more accurate inference. Additionally, its mixture of expert architecture uses sparse computation to assign tasks to specialized experts. This design enhances scalability and makes the model highly efficient for multimodal tasks. Next, let's test object localization. So I'm going to upload an image of a disk with multiple items on it, and look at this test case. We're going to check the model's ability to locate specific objects on a complex image. I'm going to upload a disk image with multiple items and ask question, locate the blue notebook. So I've found an image similarly what we are trying to achieve here. Let's try to upload it and check what is going to do with that image. So that is our second image. There's a disk there. As you can see, there is one blue notebook on that image. It's an high resolution actual image of a disk. It's not AI generated, so let's see what is going to respond for it. That is our test number 2. Whatever is on the official document, I splitted those into parts, and I'm trying to explain briefly and then do a test scenario for that brief. That's the flow we are going on today. The blue notebook is located on the left side of the disk near the bottom edge of the image. It's positioned next to some other notebooks and paper. That's perfect, precise. That's a pass, and I'm going to give 5 for that. That's good. Okay, so next, DeepSeek VL2 is trained on a diverse set of datasets including WIT and WikiHow for general vision language tasks and Oblix for multilingual capabilities. It also uses in-house datasets for OCR and QA, ensuring the model can handle a wide range of real-world scenarios effectively. Let's test the OCR capabilities with our next test case. So we are going to evaluate this module's ability to extract text and numbers from an image. So now upload a poster with text and number is our first step, and second step is extract the text and numbers from it. So I have created a image for this test case. Let's see what AI is going to respond for that. So that is my image, and I have created that page specifically with the text of my YouTube channel name and numbers from 0 to 9. What we are trying to test here is ability to extract the text and the numbers from an image. So I've added my YouTube channel name as text and then numbers from 0 to 9 at the bottom. So let's see what extract the text and numbers is our question. Okay, there is an GPU quota for it. We need to wait for 3 hours. Optionally, I have a VPN. Let's select United States and we connected. Let's try to refresh it and see what happens. Okay, let's do our image and our question. That's our image there, that's our question. Let's send and see if our VPN is gonna help us. Bam! It's helping. If you like to purchase that VPN, I will leave a link on my description. Feel free to have it. It works. It's good actually. Ah, look at that. Perfect. It gave the exact text and the numbers which is on the image. I like that. That test is passed. I'm going to give 5 for that. You can see that took my YouTube channel handle first, and then it took numbers 0 to 9 which is on that image. I like that. Okay, now let's go to our next. This slide highlights key applications of DeepSeek VL2. The model excels in general visual question answering, document QA, and interpreting data from charts and tables. These features makes it highly versatile for tasks requiring high accuracy in reasoning and data extractions. Let's test its ability to interpret chart data. For this, I've written my test case. This is for test case 5. Test the model's ability to interpret data from a chart. So we are going to upload a bar chart showing sales data. What is the trend in the chart? Okay, that is the question. You're going back and I've downloaded some chart. That's a chart. That is a data about Meta and its quarterly performance kind of things. So I'm going to ask, what is the trend in this chart? Let's assume we don't know anything about the chart and we'll see what it comes up with. That chart is having ad revenue on in billions on the one side, and the other side is having quarterly. The trend shows fluctuations with an overall increase from Q4 2022 to Q4 2024. That is exactly right. It starts with Q4 2024 and ends with Q4 2024. Perfect. And the trend actually is fluctuating. Yes. Okay, but overall increasing. Yeah, that is an right one. So that's a pass. I'm going to give 5 for this. And the next one is about DeepSeek VL2's training process includes 3 key phrases. First, vision language alignment establishes connections between the visual encoder and language model. Next, pre-training enables the model to handle complex multimodal tasks. Finally, fine-tuning improves the model's instruction following and conversational capabilities. Let's test reasoning across multiple images. Is the test case for that. Test case 4, assess the model reasoning across multiple images. So we are going to upload 3 images of different rooms and ask what's the difference. I have downloaded high resolution copyrighted images to test this. Let's see if the model describes differences accurately. So here is that. So I'm dropping 3 images of 3 different rooms. Yeah, as you can see, one is a living room, one is a dining room, one is a kid's bedroom, pinkish. So let's ask the question, what are the differences? Send. Okay. The first image has a digital background with circuit-like patterns. Okay. It features social media profile information including username, Mr. Wind, and phone number. The second image displays a bar graph showing Meta's quarterly advertisement revenue on a Q1Q change over time. It includes 2 lines representing different metrics, one for ad revenue in billions and another for percentage changes. There is no visible human figure or personal details like name or contact info present in this particular section of graphics. That is a fail. that is that's not the images what I asked the questions for. It just went to the first image from our chat and started answering. Okay, let's try to redo this after refreshing it, just avoiding those 2 images before, and I will upload just these 3 images now. I'm tempted to fail that case, but I'm giving a chance. And this case is not going to get 5. So that is the images and that's the question. Let's see now. You have exceeded. Okay, thank you very much. Let's switch to another country. Let's go India. Yeah, I'm from India now. Come on. So let's ask our question. It is processing. Okay, the difference between these images are as follows. The first the first image depicts a child's bedroom with a canopy bed, plush toys and colorful decor. In contrast, the second image shows a dining room with a wooden table and chairs, a vase of flower. That's right. And a sideboard. The third image features a modern living room with a large sectional sofa, a coffee table, and a decorative wall art. Okay, yeah. The color schemes vary across the images. The first image has a warm pink hue, while the second image has a neutral palette with beige walls and dark wood flooring. Wood flooring. Yes, wood flooring. The third image is predominantly white with the accents of black and gray. This is black and gray. It's all white. It's not predominantly black and white. Black and gray. This is wood, this is gray, this is all good. Furniture styles differ significantly. The first image includes a canopy bed with a fur blanket and a small ladder shelf. Canopy bed, floor, and a small ladder shelf. Yeah. Whereas the second image showcases a traditional wooden dining set and a sideboard. Okay, that's right. The third image presents contemporary furniture such as a sleek sectional sofa and a geometric patterned armchair. Okay, that's good. Decorative elements also vary. The first image has framed pictures on the wall and hanging lights. Framed pictures. That is not okay. There is hanging lights there. The second image features a vase with flowers and a decorative cabinet. Okay, vase and decorative cabinet. And the third image displays wall art and a minimalist coffee table setup. Yeah, that's fine. The test is a pass, but the ratings are not 5. It should find actually 3. Okay, let's go. DeepSeek VL2 outperforms many state-of-art models such as Lava OV and Intern VL2 in benchmarks like DocVQA, ChartQA, and TextVQA. Its sparse mixture of experts architecture ensures fewer activator parameters while maintaining excellent exceptional performance, making it highly efficient and competitive. So finally, we'll test a storytelling. We are going to test this model's ability to create stories for images. Upload 3 wildlife images. Create a story based on these images. This is the question, and what we are expecting is the model generates a story based on the images. Create a short story based on these images, and keep it as simple English for a 5 years old to understand. Let's see. It's waiting for the GPU to become available. Took 10 seconds, 11 seconds, and then it's processing. Okay. The GPU task aborted. Let's try to understand what happens until now. Once upon a time in the vast savannah, that savannah word is not a simple English for 5 years old. My English is bad. I'm grown up and still I don't understand that. The meaning of it unless I refer with some dictionary. There lived a cheetah named Cheeky. Cheeky was very fast and loved to hunt. One day he found a small antelope. Antelope is again, I don't know. So savannah, look up savannah, look at that. A grassy plain in tropical and subtropical regions with few trees. Okay, you could use simply a forest for kids to understand. Okay, antelope is a swift running deer like ruminant. Okay, he knew this was his chance to have a big meal, but just then he heard a loud noise behind him. It was a herd of zebras running away from something scary. Cheeky saw many birds flying around the zebras too. They all seemed scary and went trying to escape. Okay, there it is. I can pause it, but with the score of 4.5. Yeah, 4.5. Okay, that leaves us with an average of 4.58 out of 5. That's my rating out of all the 6 test cases I have run through, and that's my graph which I created for this particular videos. Going forward, I'll try to make more out sort of like this, maybe trying to make it fun and interesting. Let's see. That's our final score rating summary. 1, 2, 3 test passed good. Fourth test was little laggy. The UI, whatever it is, but the score on our test is not up to the mark, so I marked it 3. And on test 5 it is good. Test 6, the story was not exactly, it was processing the high resolution images I uploaded. 3, that was good, that part was good. And while processing and telling the story, I specifically mentioned to make it to 5 years old, and that was not exactly the kind of words I will be using for a 5 years old, and that leaves it to make me mark it 4.5. And finally the overall average rating is 4.58. To summarize, DeepSeek VL2 excels in handling high resolution images, performing OCR, and interpreting data from charts and tables. It delivers strong performance with fewer parameters. Future improvements in creativity and reasoning could make it even more versatile for complex tasks. Thank you for joining me in this detailed walkthrough and evaluation of DeepSeek VL2. If you found this video helpful, please like, subscribe, and share your thoughts in the comments. Let me know which model or technology you would like me to explore next. See you in the next video. Bye.